The Burma front offered mud deep enough to drown trucks and rain heavy enough to stall radios, yet the M7 Priest kept shouldering its 105mm howitzer into firing positions that barely qualified as ground. Tracks churned through clay, the open compartment filled with spray, and the recoil platform bit into soaked earth just long enough to deliver the shot that shifted an entire line. It was the rare machine that combined the blunt force of a field gun with the bloody-minded determination of a vehicle that thought mud was merely a rumour. North Africa revealed a crisis that artillery doctrine had failed to anticipate. The desert demanded guns that could move with armour, fire quickly, and relocate before counter-batteries sighted the dust cloud they left behind. Towed pieces lagged behind armoured brigades, their tractors overheating, bogging, or simply falling out of formation, and this slow-to-deploy firepower carved a dangerous gap between mobile assault units and the heavy support they expected to follow them. The United States realized that without a self-propelled howitzer, something fast enough to keep pace and stable enough to fire from improvised positions, the armoured thrusts planned for upcoming operations would stall under enemy pressure. 3 engineering truths shaped the requirement. First, a chassis with wide operational tolerance was needed, and the M3 and early M4 derivatives provided exactly that balance of reliability and logistical familiarity. Second, the 105mm howitzer had to retain its full ballistic performance even when mounted high in an open fighting compartment, demanding a reinforced breech cradle and thicker recoil cylinders to manage firing loads on uneven ground. Third, the crew required space to handle charges and shells rapidly, establishing the necessity of an open-top layout despite the vulnerability it introduced, because enclosed mounts slowed ammunition flow and venting. These realities formed a single strategic conclusion. Firepower had to move as quickly as armour if manoeuvre warfare was to work at all. It became the battlefield equivalent of a portable artillery office that arrived early, stayed late, and refused to file a single complaint about the terrain. The vision for a mobile howitzer emerged from a doctrinal shift that treated artillery not as a trailing asset, but as a travelling partner to armour and infantry. Designers demanded a platform capable of rapid displacement, stable gunnery, and integration into fast-moving combined arms formations. This thinking broke with older assumptions that guns should move slowly and fire from fixed lines, replacing them with a model that favoured flexibility, tempo, and momentum. The United States focused on 2 early questions: how to mount the 105mm howitzer without compromising its recoil behaviour, and how to create a compartment large enough for ammunition handling without driving the silhouette to impractical heights. To solve this, engineers elevated the gun on a reinforced pedestal and shaped the open fighting bay around the workflow of shell, charge, and breech alignment. It was an approach influenced more by ergonomics than armour theory, because delivering rapid fire mattered more than protection. It was the first artillery mount that behaved like a practical compromise, half field gun, half taxi service, determined to get the shells where they needed to be, regardless of the mood of the battlefield. Another insight came from supply doctrine. Using the M3/M4 family as the base meant the Priest inherited the same engine types, spare parts availability, and maintenance familiarity already deployed worldwide. This accelerated production and training, allowing crews to adapt to the platform without lengthy conversion. Rivals struggled with similar concepts because their industrial systems couldn't deliver the same interchangeability or volume of components, making the Priest not just a design choice, but a logistical strategy. The factories that produced the M7 Priest were asked to merge tank production speeds with artillery precision, a combination that pushed assembly lines into entirely new rhythms. Hulls based on M3 and early M4 patterns arrived as rolling chassis, stripped, modified, and reconfigured for the howitzer mount. Welders reshaped the upper structure, cutting back armour to create the open fighting compartment and reinforcing the gun platform so the vehicle could absorb repeated recoil forces without twisting the frame. A core engineering challenge lay in integrating the 105mm breech into the front superstructure layout. The weapon's mass, recoil cylinders, and elevation gear had to align with both the hull centerline and the existing suspension geometry, ensuring stability during firing. This demanded tight tolerances in machining the cradle, pivot points, and mounting braces, because even slight deviations created unwanted lateral movement when the howitzer discharged. On crowded assembly floors, this became a quality control priority, with inspectors checking weld shear lines, carriage alignment, and recoil track finish before each vehicle progressed onward. The suspension system received close attention too. Although based on the established vertical volute spring configuration, it needed reinforcement at the front bogies due to the heavy gun mass and ammunition load. Factory teams modified spring sets and increased the durability of wheel hubs to maintain mobility across rough ground. Midway through production, supply chain pressures forced several component substitutions, including alternative steel batches with marginally different hardness profiles. These were managed through recalibrated heat treatment schedules and revised machining passes, keeping structural consistency intact. It was the rare wartime vehicle whose build process felt like a negotiation between brute force and polite engineering, as if every bracket and bolt were quietly agreeing to tolerate more punishment than they were designed for. Testing the M7 Priest meant exposing it to extremes rarely tolerated by artillery systems. Trials began on proving grounds where firing arcs, recoil behavior, and ammunition flow could be measured under controlled conditions. Crews learned how the open compartment changed the rhythm of operations. Shells moved faster between stowage racks and breech, but shifting weight altered balance during rapid traverse. This insight shaped loading drills and stabilization routines that later translated directly into battlefield tempo. Firing tests revealed how the pedestal mount altered the recoil pattern. The howitzer's energy transferred down into the hull, demanding precise calibration of the recoil cylinders and breech buffer. Inspectors monitored lateral displacement, checking that the vehicle maintained position on uneven earth, even when the ground offered minimal resistance. Dust, vibration, and shock loads were all recorded to refine lubrication requirements, thermal behavior, and component fatigue rates. Mobility testing followed. On soft soil, the Priest demonstrated strong torque delivery from its power plant, using familiar M3/M4 drivetrain geometry to maintain control over churned surfaces. On slopes, the added mass at the bow required revised shift techniques to keep the vehicle steady during angled climbs. Across waterlogged ground, the high-track contact area proved decisive, letting it move where half-tracks and tractors faltered. Field exercises validated the doctrinal shift that inspired the vehicle. With armour pushing forward, the Priest matched pace, halted, fired, and relocated before hostile guns could respond. It was artillery that behaved like a punctual courier, arriving exactly when needed and refusing to loiter long enough for anyone to argue with it. The moment the M7 Priest reached large-scale combat, its true character emerged with absolute clarity. Battles in Italy, Normandy, and later the Pacific exposed the demanding tempo of modern maneuver warfare, where artillery had to move, fire, and relocate before counter-battery fire found its mark. Here the Priest's hybrid identity, part tank, part gun, part logistics compromise, proved decisive, enabling fire missions that previously required far more preparation, manpower, and time. One breakthrough appeared during rapid coastal advances. The priest could be driven straight off landing craft and into firing positions without the elaborate unlimbering that slowed towed guns. In mountainous regions, its traverse limitations required crews to pivot the entire vehicle for new bearings, but the speed of this repositioning compensated for the narrow firing arc. Ammunition supply also stabilized due to the generous internal stowage, supporting higher firing rates during intense engagements without immediate resupply pressure. At the same time, limitations became unavoidable insights. Armour protection was thin on all sides, making the open compartment vulnerable to mortar airbursts and small arms fire from elevated positions. Its height exposed it to observation, and its silhouette, large, angular, unmistakable, often drew attention long before it fired. These factors demanded disciplined movement and strict positional awareness to avoid unnecessary exposure. Yet commanders valued the platform because it provided instant artillery mobility in an era that demanded relentless pace. It was the battlefield equivalent of pairing a country lane workhorse with a city centre timetable, somehow managing brute labour and punctual precision in the same ungainly package. The introduction of the M7 Priest had effects far beyond its role on the firing line. Once armies discovered they could move heavy artillery at the same speed as advancing armour, entire operational timetables shifted. Commanders no longer waited for towed guns to crawl into position. Fire missions could follow breakthroughs almost in real time. This altered how offensives were planned, turning momentum itself into a weapon and reducing the gaps that previously invited counterattacks. A logistical consequence emerged as well. Because the Priest shared engines, tracks and drivetrain components with existing American armour, its maintenance footprint blended seamlessly into existing supply networks. Workshops didn't need new inventories, and field depots didn't need special handling procedures, reducing the usual complications that accompanied specialist artillery vehicles. This interoperability meant the Priest could be sustained in campaigns where other nations struggled to support similar concepts due to fragmented industrial output. In the realm of morale and perception, a subtler effect appeared. Infantry recognized that the Priest consistently arrived close behind armoured thrusts and that fire support was no longer delayed by terrain or mechanical fragility. This reshaped expectations on the front line, tightening the psychological link between assault units and the artillery designed to protect them. It combined the reassuring presence of a dependable escort with the punch of a mobile gun platform, a strangely confident blend, like a chauffeur who also happened to carry a sledgehammer. Propaganda offices also seized on its mobility. Images of self-propelled artillery rolling through captured towns or pushing forward under fire became symbols of industrial competence, reinforcing the narrative that American production could generate machines adaptable to any theatre. This was an unintended but strategically useful consequence of the platform's design logic. Versatility projected strength, even when the machine itself carried vulnerabilities. When the war ended, the M7 Priest didn't fade quietly. It reshaped how nations thought about mobile artillery for decades. Armies had witnessed a machine that brought high-caliber firepower forward without the delays of limbering, towing or assembling field positions. This changed procurement standards entirely. Any future gun platform now had to match the Priest's mobility or justify why it couldn't. One major legacy lay in the doctrine of follow the armour artillery. The Priest proved that guns could accompany tank spearheads without fracturing supply lines or exposing crews to unnecessary risk from slow redeployments. This idea travelled directly into post-war designs, influencing fully enclosed gun vehicles, turreted self-propelled howitzers, and the early generations of NATO standard artillery systems. Engineers continued its design logic by balancing firing stability, crew accessibility, and drivetrain strength, a triad the Priest had unintentionally formalized through its open bay and forward gun mount. Inside the fighting compartment, layout lessons were just as enduring. Ammunition racks placed for rapid human movement, breech access designed for a two-step load cycle, and recoil machinery tuned to prevent excessive hull shift all became blueprints for later artillery ergonomics. Factories studying the vehicle noted how battlefield efficiency depended not on armour thickness alone, but on workflow and crew energy management. Its legacy behaved like an unspoken engineering standard, the kind of benchmark that newer machines tried to surpass, yet quietly imitated when nobody was looking. Across Korea and later Cold War exercises, surviving priests kept serving because their maintenance routines were familiar and their mechanical logic remained sound. This longevity reinforced the idea that self-propelled guns were not experimental curiosities, but core instruments of modern war, ensuring the M7's influence stretched far beyond its original intent. The conditions that shaped the M7 Priest, mud, distance, uneven ground, and the constant need for immediate artillery, revealed something deeper about warfare. Mobility alone was never enough, and firepower alone was never decisive. The advantage came from combining them in a single platform that refused to be limited by terrain or tempo. The Priest embodied that lesson, not through elegance or armour, but through deliberate engineering choices that favoured speed, workflow, and mechanical consistency over everything else. A final reflection lies in its battlefield presence. The machine's open compartment offered vulnerability, yet it also enabled the crew to work at an efficiency enclosed vehicles struggled to match. Charges, shells, and breech movement aligned in a rhythm that kept fire missions flowing even under pressure. This interplay between exposure and productivity shaped later artillery doctrine, proving that perfect protection was secondary to achieving the necessary rate of fire when timing dictated outcomes. In strategic terms, the Priest demonstrated that standardization was a force multiplier. By using familiar engines, proven suspensions, and widely available components, armies multiplied their ability to repair, fuel, and redeploy machines at tempo. This was not merely logistical convenience, it was a structural advantage that accelerated operations from Sicily to the Pacific. It fused urgency with practicality so effectively that it felt less like a weapon system and more like an impatient colleague nudging everyone forward whether they were ready or not. The lesson the Priest leaves behind is direct. Victory often hinges not on the strongest machine, but on the one that moves, fires, and adapts with relentless reliability. It stands as a technical reminder that mobility and firepower, when paired with disciplined engineering, reshape the pace and possibilities of war. Thanks for spending your time with this video. If you'd like more documentaries on the machines and moments that shaped history, please consider subscribing. We would love to have you back.